We are the music makers, and we are the dreamers of dreams.
Acids are any H plus containing substance that is capable of donating a proton to another substance. Acids have a sour taste to turn a blue litmus paper red. Acids react with some metals to produce H2, which then dissolves carbonate salts, releasing CO2, and they taste pretty sour. When they are dissolved in water, they conduct electricity. Acids need to react to bases to neutralize their properties, and when they react with active metals, they liberate hydrogen. Bases are a substance that neutralize the acid by reacting with hydrogen ions based on ion content. Bases have the most OH negative. Most bases are minerals that react with acids to form water and salt. Bases are defined as proton, H plus acceptors. They turn red litmus paper to blue. They are slippery and bitter, like my lola. And the same with acids. When bases are dissolved in water, they also conduct electricity. There are many ways on how to determine if a substance is an acid or a base. The most common is through the use of the litmus paper. Another is by using a pH probe apparatus, which is used by submerging it into water. Another is through the use of red cabbage, really organic, right? These modes of determining acid from base use a little something we call the pH scale, which ranges from 1 to 14. The lower the number, the more acidic the substance, with 7 being the neutral number. Now let's talk about the theories regarding acids and base. Let's start with the Arrhenius theory, which is made by this Swede, Svante Arrhenius. His theory classifies a substance as an acid if it produces hydrogen ions, H+, or hydronium ions in water. A substance is classified as a base if it produces hydroxide ions, OH negative, in water. So basically, if something has H plus in it, it's a acid, and if it has OH negative, it's a base, and we call them Arrhenius acid or base. Arrhenius also differentiated acids according to their H plus. He proposed that there are 4 types of acids: the monoprotic, diprotic, triprotic, and polyprotic. Mono being 1, di being 2, tri being 3, and poly being many. These describe acids with 1 ionizable H plus or more. The next theory is the Bronson-Lowry theory. The difference between these theories is that the Arrhenius theory states that acids contain H plus and that bases contain OH negatives, while the Bronson-Lowry theory claims that acids are proton donors and proton acceptors, so bases do not need to contain OH negative. So acids donate a proton to water, forming H3O plus. So we can say that Bl acids are H plus donors and a Bl base is a H plus acceptor. And the last theory is the Lewis theory, which states that an acid is a substance that can receive an electron pair, meaning the lone pair of a particle, and that a base is a substance that can donate a lone pair, aka acids are electronegative pair acceptors and bases are electronegative pair donors. Now let's put everything into solving. The first thing I'd like to do is to determine the donor and then the receiver. So the HNO3 is the donor and the H3O is the receiver. So we can say that the substance is ABCACB. Let's try another one. The donor is H2O and the receiver is NH4. So we can say that this is BACACB. Now notice water. On the first equation, it's a base. On the second, it's an acid. This is because water can be both acid and base. We call it ample theory. Now let's try finding the pH of a solution. First, let's use the OH. Using the equation, we will input it on negative log, which means it will give us 0.119. And to find the pH, we will minus it by 14. So 14 minus 0.119 gives us 13.88, which means that the pH of this equation is basic. We use acids and bases in our everyday life, like in cooking, cleaning, anything that goes in our mouth really. Personally, it's not a concept strange to me because I'm acidic. So I'm always required to eat foods that help neutralize the acidity in my stomach. Foods like skyflakes, fruits, vegetables, which to be honest, I don't really like, but they're good for me. Acids and bases are everywhere in our everyday life. We use them for our arts, for medicine, especially nowadays in the pandemic, when we need to protect ourselves from the use of modern medicine. They're also really important since they help determine whether something is edible for us or not. That's the beauty in chemistry. Through it, it helps our lives much more easier through the help of acids and bases.
This is that one